Okay, today's lesson is 8.2, product and a quotient of function. So the product of the function is the function composition of what? The product. Composition of product of two functions. If you combine two functions, kind of you are multiplying them, gx multiplied by h of x. So this will be the product of the function. So combined quotient of function, let's say h of x equal to g of x. So this is f of x, guys. F of x, let's say, divided by g of x. So if you divide two functions, you say that this is quotient. Now let's just do an example. F of x is x plus 3 and g of x is x power 2 plus 8x plus 15. We want to find the product of the two functions. I know that y f of x multiplied by g of x, f of x is x plus 3 and g of x is x plus 2 plus 8x plus 15. I want to graph that. So to graph that, I want to write this one as a factor form. This is going to be x plus 3, x plus 5. Put it together is x plus 3, x plus 5 power x power 3 power 2, x plus 5. Now the zeros here is x equal to -3 and x equal to -5, but this is going to be order 2, right? Means if you want to graph it, it's going to be turned, and this is passed through because this is order 1. Now if I want to graph this, the zeros is 1, 2, 3, 4, 5, and here is -3. Since the degree here is 3 and leading coefficient is positive, my end behavior gonna be in these two quadrants. So I start with this, I pass through that because the order is 1, order the power is 1, and when I get here I need to turn. So here for -3 the order is 2 means it's turned. This is a graph of my function. Okay, look at that. So f of x was, now I want to do the quotient of these two functions. F of x is x plus 3 and g of x is again x plus 2 plus 8x plus 15. I want to write in a factor form again, x plus 3. Here is x plus 3, x plus 5. See, x plus 3 and x plus 3 cancel, and it's just this one. If I want to talk about the restriction, one of the restriction here is x cannot be -5. This is vertical asymptote. Another restriction is that x cannot be -3, right? But this is gonna be what? A whole. When you take it, when you graph this, you need to determine that point, which is a whole. So I want to graph this one. I know the vertical asymptote is x equal to -5. Horizontal asymptote x y is equal to 0. We did it in a first unit. Y-intercept, you put x equal to 0 is y equal to 1/5. We don't have any x-intercept because the numerator cannot be 0. So I have this information, I can graph this. So x equal to -5, 1, 2, 3, 4, 5. This is going to be my vertical asymptote. Also my horizontal asymptote, y equal to 0, so this This is x equal to -5 vertical, horizontal. Y-intercept is 1/5. Let's say this is 1, so 1/5 gonna be there. So I know my graph here is going toward the asymptote. So this one going toward the asymptote, this way going toward the asymptote. If I put a point like negative, this is -5, -6, to this one, I will get what? -1. So that would be point again. You go toward the asymptote. You go toward the asymptote. But make sure one of the restrictions that x cannot be -3 and it's going to be whole. See at -3, 1, 2, 3, we have a whole. I just put an empty circle here. So there is two restrictions again, vertical asymptote for x. And x cannot be -3. This is a whole. Okay, do the question on the worksheet that I'm going to give you, 8.2 worksheet. Gonna be homework.